So just in case you haven't read the slide yet, this session is going to be OOP for object haters. If there are any note takers in the room, you actually have all the slides are already online right now with links at the address on the first slide. Everyone got that down? Okay, awesome. So the first thing you might be wondering is, who is this weird person in front of you? And actually, I oddly kind of even look like myself today, which is a little bit weird. And do I really get that excited when I have a boarding pass for a business trip? The answer is yes. The answer to the other question is, my name is Tess Flynn, otherwise known as Socket Wench. That's Wench, not Wrench. I am the module maintainer for Flag, Flag Friend, and for examples, and I am a Drupal developer with FFW. So, objects just makes you want to smash your computer with a bat left, doesn't it? What was wrong with functions? What the heck was wrong with functions to begin with? Well, nothing. Okay, almost nothing. Okay, there's a few things wrong with them, but we'll get into that. Functions do several things really, really well. They're easy to write and use. They're great for making assembly line code. You make a thing, the function puts more things on the thing, the next one does, puts more things on the thing, and so on until it's finished. It's really good at doing that. But the problem is that functions aren't the only thing that we should be using. There's no simple way to extend a function at the language level. That's why we have hooks. We have to have hooks in order to extend the limitation of functions. Once you've defined a function, you've defined it once and forever in most languages. I know you're already looking at me, David Reed.
There's a PHP extension for that.
I know, but most people don't want to use that. There's also no easy way to encapsulate state, particularly in PHP, which does this really, really badly. PHP doesn't really enforce discipline. In a lot of languages, there's something called a struct, which allows you to actually create a standard identified, defined key value store. It's like a PHP array, but you define all the members ahead of time once and forever. And anytime you have a variable that contains one of these structs, it always has all of these members. It's not like an array where it's dynamic. Because we don't have structs in PHP and we have weak typing, it makes testing and documentation really, really hard. It's a mess. How many times have you had to go, oh, there's the hook that I need. It uses an array as a parameter. And now you have to spend 5 hours trying to track down what to put in the bloody array just to call the hook. Another problem is I'm stuck in a maze of classes, all alike. I might get eaten by an object. One of the things that's a common complaint about object-oriented programming languages is that there's huge, large structures. And it's hard to actually see what those structures are if you're not properly introduced to them. Compared to a function where once you have the function, you understand it. That's the totality. But that's also not quite true. Even in Drupal, there are interrelated sets of functions that you have to use in order to do a single thing. It's that assembly line. Wouldn't it be great if we just had one thing that did the whole assembly line at once? That'd be awesome. You can kind of do that in object-oriented programming. Also, functions and also hooks are kind of a golden hammer. Everything looks like a nail. Everything's a function. We only have if we only have that one construct, we'll use it for everything, even in places where it doesn't have key advantages that we need in order to actually finish the thing we're working on. You might have heard of this complaint before, especially if you've ever used Eclipse. I shouldn't need a 400 megabyte IDE in order to code stuff. Well, the thing is, yeah. Okay, you don't need that for a lot of object-oriented programming, but it helps. Also, there's a lot of bad IDEs out there, and object-oriented programming languages have had a lot of really terrible IDEs written for you. I'm looking at you, IBM Rational. And that can reflect very poorly on the language in which they're operating on. There are better IDEs today that are lighter, more nimble, and help you a lot more. You might also just hate this sticky little language. Why do you have this language that has all this weird stuff in it? And the thing is that, I hit my button. The thing is, a bad initial experience can taint your language. And there's a lot of bad experiences to have out there in object-oriented programming. C++ has really weird syntax in places, and it's a less modern version of object-oriented programming than we have today. It was one of the first most popular object-oriented languages out there. It wasn't the first. OOP goes back to the 1960s, actually. It's not new. It's been around for a long time. But C++ popularized wildly. And Java, oh gosh. Java was a little too object-happy. Everything was an object, and in places where it kind of didn't make sense. And then there's PHP 4, which didn't even have a finished concept of object-oriented programming in it. It was incomplete and led to a lot of weird code. All right, there's a lot of hate to be had out there. Where do we start to learn all of this object-oriented programming stuff? Well, let's go all the way back in time. Go all the way back to high school, to 3 in the afternoon when you just want to go outside and go home, and we're sitting in art history class. Anyone recognize this piece of artwork? Okay. This piece of artwork is called the School of Athens. It's created by an artist called Raphael in 1511. That's the artist, not the Ninja Turtle. Now, if we look at this particular painting, let's zoom in right on the middle of it. And we've got these two guys here. And they look like they're fairly calm, but they're actually engaged in an argument. This is actually Plato and Aristotle. And they're actually engaged in a fundamental argument about the nature of existence. They are both students of Socrates. Now, Plato actually is arguing that everything exists in this other realm where perfect things exist. If you've ever heard of the Platonic realm, that a perfect thing exists there, that's what I'm talking about. And Raphael codified this in the artwork by putting his hand up. Because he's basically saying, dude, it's like all up there in my realm. And Aristotle is just shaking his head and putting his hand out, going, you're daft, man. It's all in front of us. And stop trying to get me into your realm. It's creepy. So let's take another example. We have Plato, and he's trying to imagine the Platonic chair, the ultimate chair of chairness. But the thing is that the world keeps screwing things up and giving us all these different kinds of chairs, some of which are really, really bizarre. And Plato's sitting there going, all of these are just an imperfect copy of the ideal. So we have something called an ideal form that exists in the Platonic realm. It's abstract. It really only exists in our mind. But it also has an interesting and useful thing for us. It represents a class of real things. The Platonic chair can be thought of to represent all chairs. This is different from real objects, which are said to be physical and concrete. They may differ from the ideal, but they're still identifiable as belonging to the same class of things. Once you know a thing is a chair, it's a chair, it's a chair, it's a chair. So what does all this art history and philosophy garbage have to do with OOP? Well, let's talk about Plato in the modern age, and he's actually a programmer now. And he's sitting there trying to define the Platonic chair in his code. And so what he does is he creates class chair. And of course, his co-worker, who's working 2 cubes down, Aristotle the architect, is saying, but there's all these other chairs out here that you're forgetting about. And there's just more than one kind of chair. And Plato's saying, but they're all still chairs. We don't really want to lose chairness. We just want to extend. So we have a concept in object-oriented programming called inheritance. It extends the parent or base class. And the child class is said to inherit certain aspects from the parent. Kind of looks like this. When we have that chair class, we can have class comfy chair extends chair. Class office chair also extends chair. Class weird chair, yes, it still looks like a bizarre hand, but it extends chair. This is what we call an is-a relationship. We have an office chair is a chair. And it's said that the child class is a descendant of the parent class. And when we draw this, we draw each class as a box with a name, and then we draw the arrow in the direction that we read the sentence. So that's why it's backwards. Office chair is a chair. So you go up the chain rather than down. But chairs are boring. Let's build something more interesting than that. Let's talk about robots. Robots are fun. What makes up a robot? When we're sitting down to design a robot, we know that a robot has certain states and properties, if it's on, if it's performing a task, things like that. It has some sort of sense of internal logic so that it doesn't, bust through the side of your wall and go into the street and try to clean the nearest cab. And it also has some kind of user interface, an on or off button, microphones, speakers, a screen, things of that nature. It has all of this stuff. So when we define a class in PHP, we call class, and then we define the class name and the two curly brackets. Between the curly brackets are all the stuff that makes up this class, this robot. The very first thing we want to do is add some state and some properties. And we do that by defining what's also called a class variable. Officially, it's called a property, but a lot of people will call it a class variable. It's a variable, but it belongs to a class. It's also said to encapsulate the state of the class, because the variable lives as long as the class lives. To define a class variable, it's kind of the same way that you define any other variable in PHP. So you have your variable and initial value, but there's something kind of weird about this one, right? It's not just between the curly braces. There's this other thing here. What is that thing? We already know that there's a variable name, and that there's also an optional initial value, but there's this other thing that's in front of it, and we don't know what the heck it is. Well, that's called an access specifier. An access specifier precedes a property definition, and it has three possible values: public, private, or protected. So what do these mean? Well, let's take an example of three different robots. We have a robot called a housebot, and there's a child class called a vacuum bot, because it works in your house. And there's a completely unrelated class out there, a completely unrelated robot called an Autobot that works in the automobile manufacturing industry, because it's most certainly not referring to a cartoon. The house robot defines a public variable, a public property, a public class variable called house name. The vacuum bot has that same variable for itself because it inherited it from its parent robot. The Autobot, not related to all of this, doesn't have that variable, but it can see theirs because it's public. That's what the public specifier does. Child classes will inherit the property, and everyone can read and write the property. Now let's have a private one. We have a housebot has a private class variable called secret wish. VacuumBot doesn't have or see that. Doesn't see it at all. Neither does the Autobot. Doesn't see it. Private specifiers say that the child classes do not inherit the property, and no one else but the defining class can see or use it. There's that third case that's kind of in the middle, protected. We have a variable called protected is on, which is defined in the parent class housebot. VacuumBot has that variable too, so it can work with it as well. But Autobot has no idea what anyone else is talking about because it's not related to housebot at all. Protected specifier basically says the property stays within the family, the same quote-unquote lineage of classes. Any unrelated classes do not have or see the variable. When we draw properties, we draw it in another rectangle connected to the class rectangle. And we actually write it kind of backwards because it's a little bit more language agnostic. We have the name of the variable and optionally the type. If there are more properties, you write another one on each row underneath that in the same property rectangle. Classes can be properties too. So you can define a variable within one class that will actually hold another class somewhere else. It's actually an object, but I'm getting to that. This is what we call a has-a relationship. The hosting class is said to possess the hosted class, and we draw that backwards with an arrow with a diamond arrow. So we have our classes and they have stuff in them, but they don't do anything yet. They're still boring. Let's make them do stuff. What we have is we have methods. Methods make our robots do stuff. It's also called a class function. It gives your class some knobs and buttons, some actionable thing that you can make it do stuff with. To define methods, you define it like you would any other function, but you do it within the class curly braces. So you have function, the function name, and then a parameter and the body. There's also access specifiers on methods, but it doesn't control who can see, but who can call. So who are you going to call? Who are you going to go to allow to call? A public method can be called by everyone. Private methods can only invoke that method within the same class. Not even child classes can access it. And protected methods are only classes that are related to each other can use it. There's also a few special methods within a lot of languages. There's a huge list of them with PHP, but there's really only one you need to know. And that's a constructor. All a constructor does, it's a special method that actually builds the class. It takes the blueprint of the robot and gives you an actual robot. It's said to return an object of the class's type. It may have parameters like any other method. When you draw methods, you draw them in another box at the bottom. The method, any parameters, and a full colon, and whatever it returns, if any. So how do we build these classes? We've done a lot of defining, but we haven't actually made any yet. Well, we have our blueprint of our robot. That's what the class is. It's a blueprint. That's all it defines. But to build actual robots, we need to actually go ahead and manufacture them. And sometimes when we manufacture them, they can differ very widely from the original blueprint because we pass in different parameters. We want a different color or a different head because they're a huge Daft Punk fan, or maybe they're a Gundam fan and they want those little weird twiddly head things. Classes are blueprints for objects. They're used to build your house, not be your house. A class is the blueprint, an object is your house. You live in your house. Your house is a physical, concrete object versus a class which exists in the Platonic realm. Objects are said to live in memory, whereas classes are just defined in your code. One class can have 0 or more objects in memory. How do we make objects? Well, we use something called the new keyword. So we define a variable, new, and then the class name. If the constructor has a parameter, we can actually include that as well when we build it. This is called instantiating a class. That new keyword basically says call the class's constructor and then return a new object. That's all it does. After you've created that, it lives by itself with its own set of variables from any other object of the same class that already exists. How do you use the objects? You use an arrow operator. You can use this to access both variables and methods on the same object. So how do you use properties in methods? Use it with another special identifier. So within your method, you actually will have to access a class variable. But how do you define that from something that's a local variable within the function? Well, you actually access it just like you would any other object, but there's a special keyword called this. This set of functions here is actually called a getter and a setter, if you've ever heard of that before. So how do you talk to yourself? The this keyword actually refers to the object which owns the method. So when you call this, you're referring to that particular object. It's a special variable that exists only there. Now, that's all well and good. We've gotten through the rather dull part of building, a class and defining a class, but this is all kind of boring. Why do we even need all of this stuff? What's the cool stuff that we can actually do with this? Well, let's take two different objects. We have a base class and we have a child class. And like any, upstart teenager, the child class is going to say, I'm not like you, man. I'm going to not do your things your way. I'm going to do things my way, and it's going to be awesome. So how do we do that? Well, you might think, let's just define a different method. That works, right? But now we have a problem. We have two methods that actually do the same thing. We have a ghost class that has a method called slime that operates on a Ghostbuster. Now, if we had another child class called Slimer that also has a slime function, but we want to do more sliming. So we add another slime lots method to do more sliming. The problem is when we call this, now we have to do this mess. We have to check what the class is and then call the right method. That's just like function-oriented programming. That's what we were doing. It's terrible. Let's not do that. What we want to do is we want to assume that the class is smarter than we are, that the class knows how to handle itself more than us. We want to instead just call the same method and have whatever that method is do the right thing no matter what the class is. So how do we do that? We do that with method overloading. So we have our ghost and our slimer class, and now they both have the same method name with the same parameters. But in the slimer class, because it extends the ghost class, it does more stuff. It actually can slime more. And now we only need to know that we're operating on any random ghost object. And then we can tell it, go slime some Ghostbusters, and it will do it for us. And it will do it appropriately for its own class. But what if you still need to refer to the parent class? There's also a parent keyword. It's not a variable, but instead it accesses the class statically. How does this actually work? Well, we actually have to use the parent keyword with a weird operator called the double full colon operator. It's like the arrow operator, but only accesses the class, not the object itself. So it operates on the code, the blueprint, versus the actual object which lives in memory. You can use that in a lot of different ways to extend existing functionality. So we actually have overloaded the constructor here, and we're passing in a default parameter for our Slimer class, because we already know that all Slimer ghosts are green. So now we don't need to worry about that method. We don't need to have that parameter for every one, because we already know what it is. The class is smart enough. This works on any other method. We also call the constructor, again, the parent constructor. So it does all the rest of the work for us. So now we're extending an existing thing structurally without having to rename the method. Now, what if you want to do something a little bit weird? What if your base class says that everything that actually is of this class should have this particular method, but everyone does it completely differently? There's no way of sharing any kind of code. Anything that implements this is different. Well, we do that is we define an abstract method. Now, an abstract method is really different. What it does, it actually does not have any method body. It starts with the abstract keyword, and then it actually has no method body at all. Now, you might try, okay, this is fine, but if I try implementing this, it just blows up in my code. What the heck is going on here? When we have an abstract method, our class is also said to be abstract by default. This means that we can't actually create it. Instead, what happens is that the ghost class has to be declared abstract. Because it's so general, we can't even create one instance of it. We can refer to things as ghosts, but any actual implementation has to implement its own frighten function and its own stuff, so it knows what to do. All of this is a fancy word for polymorphism. All of this is called polymorphism, which is a fancy word which means same name, different action. So we've actually built a method which allows you to that's the same on a whole class of objects that actually can do different things, or even more things, on different individual objects. That was a lot of concepts. Let's try drawing some of this stuff. Drawing pictures can help a lot of things be a little bit clearer. So how do we do that? We have something in object-oriented programming called the Unified Modeling Language. It's really general. It's a huge library of stuff that allows you to draw a lot of different software applications. The thing is, it's huge. There's a whole bunch of stuff in UML, and it's easy to end up spending your entire year diagramming stuff. The thing is, you really don't want to do that. What you want to do instead is only draw the things which are helpful. And there's really only two diagrams that you need for object-oriented programming. One's called a class diagram. It visualizes what a class is made of and how the classes relate structurally to each other. Now, we've already seen these. Let's say that we have a class called drink. It has a few different methods and a property. We have a child class called coffee, and it has some additional methods and another property called flavorings. And we also have some other classes. We have cream and sugar. They're child classes of an abstract class called coffee flavoring. And then we want to relate the coffee flavoring to the coffee with a hazard relationship. That's a class diagram. That's a lot of stuff that we just described in one simple picture. It's made of smaller pieces, so you can break it down and you can follow the path around based on what you need. There's another one called a sequence diagram. Sequence diagrams are useful when you need to when you need to figure out the order in which things need to be done, when things need to be created or destroyed. So let's look at two different objects. We have an object called coder and an object called we have coffee. We have a line that extends down below this. This is called a lifeline, but it's basically represents time from top to bottom. Now, when the coder comes into work during the day, they start work, and then we draw a box around the entire time that the object exists. It's called an activation line. This represents when the coder is, alive, working. It's when the coder object exists. Now, of course, at some point, the coder is going to want some caffeine. So they're going to go make some coffee. So they make a copy of the coffee class. They might add some stuff to it. And then they'll drink it all the way down. And you'll notice that the activation box ends right there because there's no more coffee. Later on, coder might want some more coffee, so they go ahead and make coffee. Now, at some point, they might realize they've had too much coffee and they might get a bit of heartburn. And then afterwards, they'll have to go home. This tells us a few interesting things. One, we can call a method on ourselves in a sequence diagram. So this object is talking to itself by activating another of its own methods. Also, you'll notice that the box for the coffee is longer than the one for the coder. It exists afterwards. There's lots of useful things that we can explain here. Now, there's also something else that's really interesting. If you look at this, this doesn't really look like a lot of code. What this actually looks like is a conversation. You can almost imagine that there's two different things talking to each other. And that's what this word is. These arrows are called messages. They're not actually just methods. They can even be very general. There's a whole bunch more UML stuff. You can find that at uml.org. Don't spend too much time on it. It will hurt your head. Abstract classes are complicated. Let's simplify that. Let's just make a contract. Instead of having this huge family dynasty, like some kind of bizarre object soap opera, let's just have something simple. I need to hire some person to go clean and replace my door, and incidentally get the paper wasp nest out of my door. What we do is we make a contract. A contract says that you agree to do this, I agree to do this. It's a very light construct. In object-oriented programming, we have a thing that is a contract that's called an interface. It's like a class, but lighter. It can't be created by itself. You can't create a contract. It's just an agreement. However, the agreement itself is useful. It has to be implemented by people, by other classes. So this is what an interface looks like. Instead of class, we actually have interface. We have an interface called astromech, and it defines a few different methods by itself. Interfaces also have no properties. They're only methods. They only define what they do. And if we look at this again, you'll notice there's no method bodies either. It's just the names and the parameters. In some languages, it also specifies what it returns. Not in PHP, though. So how do we use an interface? There's a special keyword called implements. It's like the extends keyword for inheritance, but instead it implements a thing, because a class implements a contract. So if we have class R2, it extends a base class called baseDroid and implements an interface called astromech. So you can combine these constructs together for some very powerful modeling. Now, why do we want this? This just seems complicated. Why did I just got my head around abstract classes, and now you're throwing this interface thing at me? Why do we have this? Well, the thing is, you can only inherit once in most modern object-oriented programming languages. You can only have one base class. You can't have multiple. Some languages are an exception. C++ is one of them, and that's why C++ is really weird. A lot of newer ones, however, implement interfaces instead, because we only care about what we're doing. And the nifty thing is, one person can have multiple contracts at the same time, just like one class can be implementing multiple interfaces at the same time. You can think about this as a does-a relationship. We only really care about what the object does, not what it's done or what it's going to do. Only what it can do. We can define a completely separate lineage of stuff, too. The nifty part is that one contract can work on one family, and the same contract can be worked on another family of classes. And it's perfectly fine. The other thing that's more practical is that interfaces are a great place for documentation. Because they don't really contain any code, just a name of the method and the parameters, there's nothing else that's in the file. So you might as well put all your documentation there and keep your class file a lot more clean. Interfaces also love type hinting. You'll see this everywhere, particularly in Drupal 8. Instead of passing a base class as a type hint, we pass the interface, because that's more versatile. It can be anything as long as it only does the contractual stuff we're asking it for. We don't care if the contractor that's going to replace my door is Bob or Sally or whomever. We only care that they're here to replace the door. Now we only need to worry about depending on the interface instead of the class itself. You can extend interfaces too. It uses an extend keyword just like classes. And it works just like you would expect. If we want to define an interface called an R2 droid that extends the astromech interface, we can add another method to it, perhaps hide a lightsaber. Drawing interfaces is a little bit more clumsy. They're basically like classes, except that we add this interface thing just above the name. That's the only difference. How do we play nice with other robots? We're in the modern PHP era. We're trying to get off the Drupal island. We want to bring in all of these other libraries from other projects. You might be sitting there one night working on your project and go, oh, there's the library that I need. It does everything I need it to. And then, of course, you might have a problem. So in your program, you have a class called date. When you import that library, another class comes and says, hello, I am from a faraway repo, and my name is date. Of course, well then, sir, we have a problem because my name is also date. There can be only one. Now, we don't want the classes to kill each other. So what we want to do is we were going to say, whoa, 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 whoa. What if I just prefix your names? You're both called date, but what if I just add a thing to it instead? I mean, that works. Now everyone is in their own separate box. This is called a namespace. It puts classes in named boxes, and each name only has to be unique within the box. So in Drupal, we're used to a global namespace. That's why whenever we implement a hook, it has to have a completely separate name from every other function in the universe. That's why our module names have to be unique throughout the entire universe. Because if our module name was the same as somebody else's module name, they butt heads and PHP explodes. But a namespace works around this by saying everything that's in this particular bit of code is in this box with this unique prefix. And that way, if there's some other box with the same exact named object, we don't care. It's in that box. We only need to refer to the box. So when we actually refer to objects in different boxes, we can actually prefix them with a slash nation like this. Now the thing is, this syntax varies very widely across different languages. I think PHP is actually kind of onto something with their particular syntax compared to other languages, but that's my opinion. To make a namespace, we don't actually define it like a class or an interface or any of those things. We simply say that it exists in at least in one place. At the very first line in any PHP file, we can say namespace, and then we define the namespace value. And then it exists. Even if we have the same exact first line in a completely separate file, it still exists. PHP will be smart enough to go, oh, this stuff is in this namespace, this has the same namespace name, they belong in the same place. So it's fine. The problem is, you get stuff like this. Eventually you get these huge, unruly, bizarre class names with this huge namespace environment. I don't want to refer to a huge whole path like this. This is a mess. What we have is something called importing. And what it is, at the very top of your file, you use something called a use statement. And now we actually have the really long namespace class name with the name being the actual class at the end. And we're just going to say import that into the current namespace for this file. So now we can just refer to it as name from this point forward. We don't need to actually do anything else or prefix it again. We've imported it into our namespace. But what if we have two classes that have the same exact name and we want to import them into the same namespace? Well, we actually have something called aliasing. And it basically imports and renames at the same time. So if we want to be a particular jerk, we can rename a class bad guy, and then we just treat it as if the class was named bad guy the entire time. How do we structure these modern object-oriented programming projects? Every language does this a bit differently. No one does this exactly the same. There's always little tiny differences, but there's some common patterns that have emerged. In general, you want to only make one class or one interface per file. This is very different from what you've been used to in Drupal 7 and earlier, because in Drupal 7, we're used to huge, gigantic files. In Drupal 8, we have lots of little files. And the reason why is it's actually easier to do a lot of nifty under-the-cover stuff if we have one class per file. Also, the file extension typically is the default for all of your language. So we don't use .inc, we don't use .class, we don't use any of those in PHP. We just use .php. When we make directories, we're going to actually match the namespaces. So if we have a nested namespace, we have nested directories. It looks like this. Here's our really, really long namespace here. And it actually looks like this towards the end. So we have a movie directory that contains the Highlander directory, that contains the McLeod directory, that finally contains the class that we want to have. Also, in a lot of projects, there's also a root namespace directory that contains all the source code for your entire project. This is different between different communities and different languages. PHP is kind of settled on a source directory. How do we work in OOP? First of all, the most important piece of advice I could ever give you is to think in conversations, not in steps. Don't think about this as an assembly line where things are built incrementally. Think about it more like a movie script. You have a character who's responsible for a thing, who needs to talk to another character who's responsible for a thing. Instead of focusing on the things that they're doing, you focus on the characters that are acting. By thinking about the characters instead, and thinking about the conversation that they're having, it's a lot easier to get the bigger picture together. You're following the characters, not their individual actions. Also, don't fear the whiteboard. A little drawing goes a long way in object-oriented programming. It can help. It can really make things a lot easier. Also, I hate to admit it, but an IDE does help. A lot of IDEs actually will make your life a little bit easier. Find one that you don't hate immediately. You'll still probably hate it for a long time, but then eventually you'll go, huh, that was useful. Now I don't hate it as much because it does more of the stuff I need it to do. Also, love the documentation. One thing that object-oriented programming does well is it does documentation pretty well. And the reason why is because unlike a huge array of Doom, we can document every property, every method, every parameter. We can document it all the way down at the language level versus at a community level. This means that if we need to build a structure, we know that it's probably some class somewhere. Oh, this class needs to have a parameter of this class. You go to that particular class's documentation and read how to build it, and so on. It's like thinking about that conversation. How do I get the person who has the right role for this particular job? Also, you might want to let go a little bit. I know if you're a function-oriented programmer, you might really like to have everything in your head, the entire list of steps, but it's much easier to let go a little bit and think three-dimensionally with multiple conversations going on with much more complicated structures. Object-oriented programming compartmentalizes things really, really well. That's one of the main reasons why it exists, so it can compartmentalize things. You don't need to know everything, just the characters that you're talking to, just the classes you're talking to. Where can I find more stuff about all of this? There's a really theory-heavy book called Design Patterns that's by a guy called Eric Gamma, which talks a lot about really common tried and tested patterns in object-oriented programming, and it does it in a language-agnostic way. It's a really handy resource if you want to get used to some of the bigger patterns of how objects can do things and learn nifty object-oriented tricks. There's also PHP the Right Way, which will give you a lot more practical advice on working with PHP. There's a book called Modern PHP by O'Reilly. These are links, by the way. And there's another book called A Year with Symfony. And A Year with Symfony actually isn't about object-oriented programming, but it tells you a lot about how to think with Symfony, and Symfony is very object-oriented. All right, you can find this presentation on github.io. Any questions? Probably a lot.
The design patterns book you mentioned, and is that the Game of 4 one?
Yes, it is.
I thought that name sounded familiar.
Yeah, that one's considered a seminal book.
Can you put the link back up?
Yeah. Come on. There you go.
Thank you.
Mm-hmm.
Yeah, go ahead.
One question. You might have mentioned it, but
What?
can interfaces be inherited?
Yes, I did. I did mention that. So you can inherit an interface. It works just like classes actually. You extend them.
Right.
There are some of those that happen in
Well,
the
you can extend interfaces, but if I put an interface on the parent, can I use it on the child class?
Yeah. It's brought in with the rest of it.
Okay, that's kind of what I'm curious.
What about traits?
No, we need to like that one.
And what did you mean when you said that there's no method body on interfaces?
So with an interface, you don't actually define any code that does so.
Okay, all that's defined in the class.
That's defined in the class, because the class actually implements it.
Yeah.
So that's what it does. Okay.
This is all coming together now in my brain, so it's really helpful because like kind of like waded through looking through some of the type of stuff. Just tried to learn that stuff, but this is like really looking to crystallize it. So really good explanation.
And with the double dots, oh my gosh.
You need a double
Yeah,
colons?
yeah. So
I know there's
four
a name
dots.
for that, but I don't know what it is anymore.
Around, there's no line when
I want to say that it's a static member accessor, but God, that just sounds like something I managed to do.
A static member on its own just sounds.
I don't know the official name, but
I think I've seen that sometimes where it's just like Drupal colon.
Yeah, so that's one thing I didn't quite cover because it's complicated to cover everything in an hour talk, but there's something that we can actually access certain things statically. So I didn't talk about static members at all in the presentation, but there's a static keyword. So if you can define a class, like a Drupal class, and you need to define a constant in the class, you might go, let's say you have static and then a variable, and then now that variable exists even if an object doesn't exist. A static one is like saying, this thing belongs to this class, but it lives by itself forever.
Yeah, and static methods can be invoked without having an instance of the class.
Yeah.
They're essentially like functions.
That's why you can get Drupal for service.
So service is a static method on the Drupal class.
Mm-hmm. Now we could just have the service function, but think about that for a minute. That's a bit like, who owns it? What's it do? But if you attach it to the Drupal object,
yeah, that's how you get auto loading capabilities.
Yeah, that's another.
You don't have to have your functions all in one file and always make sure that's included in a class.
That's one nifty thing that in modern PHP that you can actually do with objects that you can't do with functions. You know how you used to separate off certain things in completely separate PHP files, like you have a menu item, you say, oh, it's in this file because it's this huge form and you only need to load it once. Wouldn't it be nifty if at the language level you can say, just load the stuff I need and not every bit of code in my entire project? That's actually what you can do with objects. Because if you actually if you refer to an object that hasn't been loaded yet, you can configure the language to go, oh, I'll just go and pull that class in because it's in this namespace down this directory tree and it's over here. I'll load it for you. And that's what it's called auto load.
so I've been in the community for almost 8
everyone's showing their colors. They're like, oh dear God, we're finally getting off the island and all this jazz. You're rocking the objects. This is amazing. What have you and everybody else like you've been doing for all this time? Just holding it in and like, these closet object lovers. How have you survived in procedural Drupal so long? And hey, and anybody else?
But I try not to think too much about it. See, a few years ago, the very first thing that I did when I sat down and said, I've been using Drupal for years now. I want to actually understand how this is. And I got a debugger and I got a book of Pro Drupal 7 development and I started going through the whole thing. And by the third night, I was terrified. Because it's like, no, really, you just use dynamically generated function names and then just call them like oh my God. It's weird and it's terrifying how Drupal actually exists because we've had to re-implement constructs in the software layer that should be in the language layer. The language should be doing this for us. But the thing is that Drupal started in PHP, and PHP's object support sucked terribly until 5. If you've ever tried to do any object stuff in PHP 4, you'll just be banging your head on the table the entire time, like I was, because it's not a fully fledged object-oriented language in PHP 4. In 5, it got a lot better. It makes a lot more sense now.
Oh, seven, done anything with it? Have you looked at it?
You mean, PHP 7. No, I haven't looked at it yet. So, I don't know. Most of the language constructs that I was most interested about finally got in the language in 5. So, that's the reason why I got into Drupal 8 is because, finally objects. Now I'm going to be interested in this particular project and how it's actually made and built because before it was weird and difficult. I can't explain to you how incredibly frustrating it is as someone who is used to working with objects in object documentation, where everything is documented and I only need to know what class I need to get, to actually go and figure out what array I need to build. It's just, oh my God, it's terrifying. I mean, sometimes I can't even figure it out, and I have to go into Drupal, set a breakpoint in a debugger, and then get the array directly because it's not documented properly. And this is another weird workaround. That's why we have these huge arrays of doom, because we're trying to work around a lack of a particular language construct in PHP. And PHP never bothered to create a struct construct because it decided that you might as well make class constructs. You can make a class that doesn't have any methods in it, and that is effectively a struct. That is what a struct is. It's a class with no methods, where everything's public.
Drupal 9, we kill the render array.
I'm so looking forward to that. I want to kill the form API I did. I want to kill the form API I did, but I don't want to use Symphony's form builder.
Right.
I hate Symphony's form builder. It's way too dynamic. I want something that actually uses IDE completion, so I don't think as much. Alt-Shift, that saves my life so many times.